This is the video for accelerated geometry on day 2 of section 7.3 on compound events. If you recall from yesterday's video, we did the Venn diagram for compound events. What I want you to do before we even get started is to pull out your video or pull out your notes from yesterday on the Venn diagrams so that you can look at those examples, because those Venn diagrams will come in handy as we're actually working the same examples but calculating probabilities today. So the first type of probability we're going to calculate is the mutually exclusive events. The probability of two mutually exclusive events, A or B, occurring is just the sum of their individual probabilities. So if you have the probability of A union B, and there's a reminder down here that this symbol just means union, and that this symbol really is just saying the probability of A or B is just equal to the probability of A plus the probability of B. So if I'm rolling a number cube, the probability that a number is less than 3 is the same thing as saying the probability of a 1 or a 2. The probability of a 1 is 1 out of 6. The probability of a 2 is 2 out of 6. I'm sorry, 1 out of 6. So when you add these together, 1 out of 6 plus 1 out of 6 is 2 out of 6. And 2 out of 6 reduces to 1/3. Example 1 is the same thing as example 1 from yesterday where we drew the Venn diagram, but we're actually going to calculate the probability now. So we have the group of students is donating the blood during a blood drive. A student has a 9 out of 20 probability of having type O blood and a 2 out of 5 probability of having type A blood. What is the probability that the student has type O or type A blood? So we have the probability of type O union with type A, which is just going to be the probability of type O plus the probability of type A. So the probability of type O was 9 out of 20 plus 2 out of 5. And when we add these together, we get 17 out of 20, which is equal to 0.85 or 85%. Example 2, each student cast 1 vote for senior class president. Of the students, 25% voted for Hunt, 20% voted for Klein, and 55% voted for Villa. A student from the senior class is selected at random. What is the probability that a student voted for Klein or Villa? So I have the probability of Klein or Villa is just equal to the probability of Klein plus the probability of Villa. So Klein had a 20% and Villa was 55%. Add them together and we end up with 75%. Next, let's talk about how to calculate the probabilities for our inclusive events. So the probability of two inclusive events, A or B, occurring is just the sum of their individual probabilities minus the probability of both occurring. So the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A and B. So for example, if we're rolling a number cube and we have our Venn diagram down here at the bottom showing rolling an even number or a prime number. So as you can see, there's 3 numbers inside the red circle, which gives you the probability of an even is 3 out of 6. There's also 3 numbers inside the blue circle, so the probability of a prime is 3 out of 6. But there's 1 number in the overlapping section, so we have to subtract off what they overlap, which is the 1 out of 6. So 3 6 plus 3 6 is 6 6 minus the 1 6 equals 5 6, or as a decimal you would have 0.833 or 83.3%. Okay, let's work some examples. You're rolling a number cube and I want to find the probability of each. So rolling a 4 or an even. So I know that these are inclusive because 4 is also an even number. So the probability of a 4 or an even is going to equal the probability of a 4 plus the probability of an even minus the probability of a 4 and even. So the probability of a 4 is 1 out of 6. An even number is 3 out of 6. And the 4 and even would be 1 out of 6, which just equals 3 out of 6, which reduces to 1/2 or 0.5 or 50%. What about rolling an odd number or a number greater than 2? So before you get started, you know that this is inclusive because when you think about it, you know that there are odd numbers greater than 2, 3, and 5. So we would have that the probability of an odd or greater than 2 is the probability of an odd plus the probability greater than 2 minus the probability of an odd and greater than 2. So probability of an odd, there's 3 odd numbers on a cube. Greater than 2 would be a 3, 4, 5, and 6. So that's a 4 out of 6 minus odd and greater than 2, which is 3 and 5. So that's 2 out of 6. So 3, 7, 7 minus 2 leaves me with 5 out of 6, or 0.833, or 83.3%. Okay, looking at a deck of cards, find the probability of each. Drawing a king or a heart. So the probability of a king or a heart is equal to the probability of a king plus the probability of a heart. And then is it possible to have a king that is also a heart? Yes. So we have to subtract the probability of a king and heart off. So in a deck, there are 4 kings. There are 13 hearts. And there is 1 card that is both a king and a heart. So 17 minus 1 is 16 out of 52, which will reduce to 4 out of 13, or as a decimal, you would have 0.308 or 30.8%. Drawing a red card or a face card. So as we talked about yesterday, there are face cards that are also red. So this is going to be inclusive. So the probability of a red or a face is the probability of a red plus the probability of a face minus the probability of a red and face. So in a deck, there are 26 red cards. There are 12 face cards. And there are 6 cards that are red and a face card. So 26 plus 12 minus 6 leaves me with 32, which reduces to 8 out of 13, or 0.615, or 61.5%. What about not drawing a black or a 5? So this is essentially asking you for the probability of the complement to black or 5, which we know is just going to be 1 minus the probability of a black or 5. So if I find the probability of a black or a 5, that's going to equal the probability of a black plus the probability of a 5 minus the probability of a black and 5. So there are 26 black cards. There are 4 5s. And there are 2 5s that are black. So that comes out to equal 28 out of 52. So if I go back and plug this in, we have 1 minus 28 out of 52, which will give me 24 out of 52, which reduces to 6 out of 13, or 0.462, or 46.2%. Okay, what I want you to do at this point is, if you haven't already been doing so, please pause the video while everybody finds the last 2 Venn diagrams from yesterday's notes with these 2 word problems that we did. Okay, so the first one is, of 1,560 students surveyed, 840 were seniors and 630 read a daily paper. The rest of the students were juniors. Only 215 of the paper readers were juniors. What is the probability that a student was a senior or reads a daily paper? So we want the probability of a senior or reads daily. And if you notice from the Venn diagram that we did yesterday, they did overlap. So these are inclusive events, which tells me that it's going to equal the probability that they were a senior plus the probability that they read daily minus the probability that they were a senior and read daily. So we know that there were 840 seniors out of the 1560. We know that 630 read daily. And then if you look at your Venn diagram, how many were in the part that overlapped? And if you look, you can see that there were 415 in the part that overlapped. So if you take 840 plus 630 minus 415, that will give you 1,055, which will reduce to 211 out of 312. As a decimal, that is 0.676, and as a percentage, that is 67.6%. One more. Of the 160 beauty spa customers, 96 had their hair styling, 61 had a manicure. There were 28 customers who only had a manicure. What is the probability that a customer had a hairstyle or a manicure? So we have the probability of a hairstyle or a manicure. And if we look at our Venn diagram that we already drew, we see that they do overlap, which tells me this is an inclusive event. So it's the probability of hairstyling plus the probability of the manicure minus the probability of hairstyling and manicure. So we know that 96 out of the 160 had the hairstyling, that 61 out of the 160 had the manicure. And if we look at our Venn diagram from yesterday, there were 33 in that overlapping section. So 96 plus 61 minus 33 leaves me with 124. Which will reduce down to 31 out of 40, or 0.775, or 77.5%.